This demonstrates the formation of emission spectra. When a high energy electron from outside the atom collides with an orbiting electron inside the atom, some of the outside electron's kinetic energy is absorbed. It excites the electrons inside the atom into higher unstable states. When they drop back to fill the vacancies created, they have to give up energy as electromagnetic waves. Here we can see certain wavelengths of electromagnetic waves are emitted depending on where the electron falls from. So if we see, we've got various bands of electromagnetic waves depending how far this electron falls. Every element has a unique signature of emission spectra. If we look at helium, we can see that this one has different energy levels and therefore produces different bands of electromagnetic waves. Oxygen is a much more complex atom, therefore produces many different bands of waves. If we were to look at the light passing from a distant star, we would see what's called a continuous spectrum. What we generally see is a continuous set of wavelengths. However, if the photons from the star's inner core passes through cooler outer layers of the star with certain elements in it, what happens is the atoms of those elements absorb the photons. This knocks the electron into an excited state. As those electrons fall back, you can see that the photons get sent off in a totally different direction to the observer. So what happens is the observer doesn't see those wavelengths coming from the distant star, and a dark portion appears in this absorption spectra as shown. Those wavelengths are missing from the continuous spectrum. Only those photons with exactly the right amount of energy to knock the electron into a higher energy state are absorbed. This gives us the ability to work out what elements are in stars by comparing the absorption spectra from the star with an emission spectra that we've created in the lab. Notice each element has its own unique absorption spectra. The dark lines appear in very different places compared with the other element we've just looked at. If we take a look at oxygen, we can see a very different set of bands